In this lesson, we'll be talking about algebraic expressions. Our guiding questions, we want to make sure we're trying to decide what the difference between a numeric expression and an algebraic expression will be, and what the difference is between the terms simplify and evaluate. The first problem we're going to look at deals with modeling words with an algebraic expression. Given a word phrase, am I able to write an algebraic expression to model that word phrase? So if we look at this first problem, which algebraic expression models the word phrase 7 fewer than a number t? 7 fewer than. 7 fewer than a number t. The key word there is than. Fewer than means then I've taken that away from something that's already there. So 7 fewer than means I would have t minus 7. 7 fewer than. Again, look over here at this think box. It helps you to try to clue in on what is important. Now I'd like for you to do the Got It Problem 1. To model a situation with an algebraic expression, you need to make sure you're doing the following. First, identify the actions that suggest operations. Am I using multiplication, division, addition, or subtraction? Second, define one or more variables to represent the unknown. Define your variable. And third, represent the actions using the variables and the operations. If I look here at problem 2, you start with $20 and save $6 each week. What algebraic expression models the total amount that you save? I start with 20 and save 6. That suggests addition. What do I not know? I don't know the number of weeks. So that's going to be my variable. So what algebraic expression goes along with these words? I start with $20 and I save $6 per week, which means 6 times W, which is the number of weeks. Now you need to do Got It Problem 2 in the same way. When we evaluate an algebraic expression, you substitute a number for each variable in the expression, then simplify. So when we evaluate, we first substitute, then simplify. So referring back to our guiding question, what is the difference between evaluating and simplifying? Simplifying, we just get to the answer. Evaluate, we substitute first, then simplify. Problem number 3. What is the value of the expression for the given variables? When we evaluate, first we substitute values in for the variable, which is what it's done right here. Then we can either follow our order of operations, or we can just put that in our calculator, just like we write in our substitution step. If we were to put this in our calculator, we end up with 7. You put that in your calculator and you try and see if you can get 7. Now for example B, I'm going to do the same thing. In place of my X, I put 1. In place of my Y, I put 1/2. Then I'm going to put that in my calculator and I'm going to end up with 3/4. Practice putting that in your calculator, making sure that you can get 3/4. Be careful how you put in your fractions. If you have trouble with these, make sure and talk to me in class about it. Make sure you do Got It Problems 3A and B. We're going to be writing and evaluating expression in this problem. In football, a touchdown is worth 6 points, an extra point kick is worth 1 point, and a field goal is worth 3 points. What algebraic expression models the total number of points that a football team scores in a game, assuming each scoring play is one of the 3 given types? First, I need to define my variable. The 3 things I'm talking about: touchdowns, extra point kicks, and field goals. I'm trying to find out how many of each. So those are going to be my variables. So I'm going to let D be my number of touchdowns. I'm going to let E be my number of extra point kicks. And I'm going to let F be my number of field goals. So now to figure out the total number of points in the game, I'm going to take however many points that I get for each touchdown, which is 6 points per touchdown. I'm going to add how many points I get per extra kick, which is 1 point. So that would be 1 per extra point kick, plus however many points I get per field goal, which is 3. So that'd be plus 3F. So that would be the algebraic expression. Now it asks me to suppose a football team scores 3 touchdowns, 2 extra point kicks, and 4 field goals. How many points did the team score? I'm just going to evaluate. I'm going to substitute those values in for my variables. 3 touchdowns, 2 extra point kicks, and 4 field goals. So I substitute them in, and I end up with 32 points. Now I would like for you to do this Got It problem 4. An expression is a number, a variable, or the product of a number and one or more variables. The whole thing is called a term. So an expression that's a number, a variable, or the product of a number and one or more variables is a term. A coefficient is the numerical factor of the term. A constant term is a term with no variables. You can add terms to form longer expressions. Looking at our example here, we have 3 terms in this expression. Negative 4ax is a term. 7w is a term. And negative 6 is a term. Make sure when you're looking at the terms, you look at the sign in front. If there's a minus sign in front, that term is negative. Looking at the terms, I can then say that negative 4 is the coefficient of that term, and 7 is the coefficient of that term. And then negative 6 would be our constant term. Like terms are terms that have the same variables raised to the same powers. If I look here at this example, I can see that 3x squared and 5x squared are like terms. They both have a variable x squared. So those are like terms. Also, 9y cubed z and negative 4y cubed z are also like terms. The y cubed z being the parts that are alike, that make them the like terms. We can simplify an algebraic expression that has like terms. We do this by using the properties of real numbers from our previous lesson, as well as the following properties. When we combine like terms, we add or subtract coefficients. Variable parts stay the same. So if I was simplifying this expression right here, in the like terms 3x squared and 5x squared, I would add the 3 and the 5, and I would get 8x squared. Then I would take the 9y cubed z and minus 4y cubed z, which would give me a positive 5y cubed z. And then the 2yz just stays as it is. There's nothing to combine it. This chart gives us a concept summary for the properties for simplifying algebraic expressions. All these are things you already do, but it's just giving specific names to them. I'd like for you to read over this and just make yourself a little bit familiar. Remind yourself that these are all things that can be done when simplifying expressions. So in this problem 5, we're going to actually simplify some algebraic expressions. We're going to combine our like terms to come up with the simpler form of the expression. So in example A, I can combine 7x squared with negative 4x squared, and that gives me 3x squared. Then I can take 3y squared plus 2y squared, and I get 5y squared. So that would be the simpler form of the original expression. I combined the like terms. Looking at example B, let's just follow along. We have everything done for us. First, we have to do our distributive property to get rid of the parentheses. So I multiply negative 1 times 3k plus m, and I get negative 3k minus m. Then I multiply 2 times k minus 4m, and I get 2k minus 8m. Then I combine negative 3k plus 2k, which gives me negative k, and then m minus 8m, negative m minus 8m, which gives me negative 9m. So I end up with the expression negative k minus 9m. Now I would like for you to do the got it problem 5.